want to talk in this section a little bit about monomials and polynomials. First, a monomial, it's a term that has no variable in the denominator, and its variables that it does have, if they have exponents, they only have a whole number exponents, like 1, 2, 3, 4, 5, those whole numbers, no fractions, and of course no negatives, because that would send it down into the denominator of the fraction, and this has to have no variable in its denominator. Now, we don't care if the coefficient, the leading number, is negative. That's fine. This variable here that we have, the y, it has an exponent of 1, so it's okay. 8, of course, 8x squared, exponent of 2, that's fine. 12 has no variable at all, but it's also considered a monomial. And this one, 4/5, a squared, b squared, well, the 4/5 is just the coefficient. It's okay if that's a fraction, so long as the exponent itself is not a fraction. Now, it doesn't have variables with negative exponents in the numerator, of course. Positive exponents are in the denominator, would be a negative exponent in the numerator, and it doesn't have fractional exponents. So those are the three things that you might want to really keep in mind here. I'll put a star by that one. And the degree of a monomial is the next thing we're going to talk about. The degree of a monomial that has more than one variable, well, we would add the exponents of its variables, and that would be how we would find the degree. Right, I think I've got that covered, except for I did talk about the coefficient is the number in front of the term. The number in front is called the coefficient. That would be k. It's any real number that we have. And of course, the exponent for a monomial is positive, and it's a whole number, okay? So now let's look at these and see if we say, are they monomials or not? Well, we got 2x to the power of 4. Positive exponent in the numerator. So this one is, yes, it is. So now we're going to look and say, what is the coefficient? Well, that's the leading number. In other words, that's the 2. And what degree does this monomial have? Well, the highest exponent degree is what we're talking about, the highest number of exponents. And this one only has one exponent, so the degree of this one is 4. So we would say it's a 4th degree monomial with a coefficient of 2. Now, the next one, I'm going to say, well, that one, is it a monomial? Yes. Well, yes, it is. It doesn't have any variables in it, but the coefficient is there, isn't it? And that would be a 9. Well, what's the degree? In other words, what are the exponents? Well, any variable that you had, let's just pretend we had an x to the power of 0, right? Anything to the power of 0 is the number 1. So this is assumed that any variable it has an exponent of 0. And that's why we can say it has a degree of 0. Now the next one, 5z to the negative 2. Well, you know that this is a negative exponent, and that is not part of our definition for a monomial term, so we have to say no for that one. And we don't really look at coefficient and degree for those. And the next one is 3x to the 5th y squared. We would say the monomial, yes, it is. Does it have a coefficient? We would say the number 3 is our coefficient. What's the degree? Well, we're going to add the exponents for the two variables. We're going to say 5 plus 2 is 7, and that's the degree of that term. Remember, we're considering the degree of the entire term here. Next, I've got 4, and it's ab to the power of 1/2. Now that is a fractional exponent, so this is not a monomial, and we don't really have to answer the coefficient degree questions then. So, taking care of a monomial, now let's talk about what a polynomial is. Now, polynomial is actually a monomial. It could be a monomial with just one term. That's a special kind of polynomial. Or it could be multiple, the sum of different monomials. A binomial is a special one that has 2 terms, and of course a trinomial you would assume had 3 terms, and then anything more than that we would say is just a polynomial, a 4-term polynomial, 5-term polynomial, and so on. Now, the degree of the polynomial, highest degree of any term. So we look at the term that has the highest degree, and we call that the degree of the polynomial. What's the coefficient? Well, that highest degree, the term that has the largest degree, the leading coefficient in front of that term, that's what we call our leading coefficient for the polynomial. So let's take a look at some down here and see what we've got. I've got 9x to the power of 7. Now that fits the criteria for just a monomial, which is also a polynomial with one term, isn't it? The degree, where we're looking at our exponents, is 7. What kind is it? Is it a special one? Yeah, it's a monomial. We'll write that down. And the leading coefficient is 9 for this one. Now we've got our terms written in the next one from the highest degree to the lowest, 4, 3, and 2. And that looks like they're all positive and there's no negatives, and it's fine. This is a polynomial. It has a degree. We're going to look at that very first term. The highest degree of this term is a 4. This one will be a 3. This will be a 2. The highest degree for this one is a 4. So we're going to say the polynomial is a fourth degree polynomial. And what is it? Well, it has 1, 2, 3 terms, doesn't it? Remember, terms are separated by addition or subtraction. So that's the 3 separate terms you see here, and we would call that a trinomial. What's the leading coefficient? Well, I know that 8 is bigger than the coefficient of the x to the 4th, which is only a 1. We assume a 1 out there if there's no number. But we still have to pick the coefficient of the term that has the highest degree, coefficient of the term with the largest degree. So we have to say the leading coefficient is a 1. Let's take a look at the next one. This one has a fraction in it that has a variable in the denominator. And that means that particular part is not a monomial. So this one is not really a polynomial. So we have nothing to say about the rest of it. And another one, the example D, when we look at it, it has a fractional exponent, which means that part of it is not a monomial, so it can't be a polynomial. And we'll take it off our list too. Now, on the next page, I want to go back and do a little bit of a review with you, just sprinkling this in there where I have time. And I want you to look back at functions and just remember what we did. We said that a function was anything of x, right? F of x, g of x. This one is labeled p of x. And they're saying p of x is equal to x squared plus x plus 4. And then they give us another function, q of x is equal to 9x squared minus 4. And they want us to find p of 7 and q of negative 9. So we're going to take our p of x function and we're going to plug in 7 for x. In other words, I'm going to say p, when x is 7, what is y, right? Remember, this is going to be y is equal to, right? So y is going to equal to, well, I'm going to plug in 7 for x, 7 squared plus 7 plus 4. That's going to be, we'll do the exponent first, 49 plus 7 plus 4, which is really 49 plus 11. So I think I can do it in my head. It's going to be 60. What am I saying? P of 7 is equal to 60. I could think of that as y equals 60, right? And if I were to look at what x is, well, x is 7, isn't it? And y is 60. What is the solution that I found? Could be considered one point on that function, in that function, 7, 60. Let's look at q of x. This time we're going to plug in negative 9 for x. Whenever you're plugging in a negative, you have to be extremely careful to keep it in parentheses because exponents will really mess you up. This time we have q of 9, or q of negative 9 is equal to 9 times negative 9 squared. Now, the x is squared, so the entire thing, negative 9, is squared. I am squaring the negative in this case. It's different if I don't square the negative. It makes a different answer for me quite often. So this time I'm going to square negative 9 first. I'm going to say that's 9 times 81 minus 4. And then I'm going to cover this multiplication next. I'm going to go 9 times 81, which I believe gives me 729, and subtract 4. And of course that would give me 725. Now remember what I'm doing here. Y is equal to 725. What's x? Well, we just plugged it in, didn't we? We put negative 9 for x. 725 is what we solved for y. That's just a reminder so that you don't forget what we have done, because as we go through our functions, as we go through working with polynomials here, it's easy to forget what you've been doing with graphing and functions. Okay, let's take a look at addition and subtraction with polynomials. Now, this is multiple terms. They may have parentheses around them, they may not, but we're going to assume that if we add two polynomials, and this example is two trinomials, isn't it? If we add two polynomials, and they're both written in parentheses, we don't really need parentheses. Addition in between them, it's not going to change anything. So you can just drop the parentheses, and then you can combine the terms that are alike, and then you can add the coefficients and keep the variables and the exponents, okay? So let's kind of do this. I'm going to bring it down without parentheses. And that's minus 6. So I brought it all down on one level, and now I'm going to see for like terms. What do I have? Well, this one is a y squared. I always start with the highest degree term, okay? So these are the y squareds. I've got 6y squared. 6y squared plus 9y squared, well, that gives me 15 of them. 15 y squares. And then I have a positive y, that's 1y, and this is a negative 1y, and they will basically cancel each other out. It's like 1 minus 1, that's going to be 0. Next, I'm going to have negative 6, negative 7. Negative 6 minus 7, well, I'll add them together and keep the sign, so I'm going to end up with negative 13. I've successfully combined all of my like terms, and you can see that I ended up with just a binomial from this. Next, what happens when we have the exact same two polynomials, but this time we are subtracting them? Well, this time I have to be careful. I have to distribute this negative to each term inside parentheses. In other words, it's going to change the signs. Now, I don't really have to worry about the first polynomial, the first trinomial. It's going to just be the same. I just bring it down. But as I distribute that negative and take away the parentheses, I say, it's almost like saying negative 1 times 6y squared, negative 1 times negative y, well, that gives me a positive y, negative 1 times negative 7, that gives me a positive 7. And now I can start combining like terms. Once again, I'm looking for the highest degree first, and be sure you keep the sign that's in front of the term with it. So this is 9 minus 6 this time for the y squares. I'll end up with 3y squared. And this time I have a positive y here and a positive y here. Well, that's 1y plus 1y, so that's going to be 2y. And next I have negative 6 plus 7. Well, that's like 7 minus 6, so it's going to be plus 1. This time I end up with a trinomial, 3 terms. Okay, I'm going to do a couple more of these. Remember, when addition is between two polynomials, you just can drop the parentheses and combine like terms. When subtraction is between them, you have to distribute the negative, and then you go through the same process. Now, I'm going to bring these down a little bit differently because sometimes it helps to see things another way. And I'm going to match the terms up on top of each other. This is a positive 9y squared. And this is a negative 8y. And this is a positive 4. Now, I'm just lining them up. I'm going to make sure everything has a sign so I know when I combine them what I'm doing. I'm going to add 2 and 4 because they're both positive. I'll add these two and keep the sign also. And then I know this is going to be a positive 16y squared. I don't really have to write the plus in front of it. Sometimes it is easier if you can just line them up on top of each other rather than writing them out in a line and then trying to go search for what matches. Let's do the same thing over here when we subtract. First, I'm going to say 7y squared minus 8y plus 2, and then I'm going to distribute my negative. Now I'm drawing these lines so that I don't forget. That's going to be a negative 9y squared. We can go right in front of, or right over here with my positive 7y. And I'm going to have a positive 8y. And I'm going to have a negative 4. Now this was a positive 7. That helps me. And what am I saying? I'm saying 2 minus 4. That gives me a negative 2. In this one, I've got negative 8y, positive 8y. Well, they really cancel each other out. That's 0. And then I have a negative 9y squared, positive 7. I'm going to end up with a negative 2y squared. So put it all together, if you will, because they're a little spaced out. And I have negative 2y squared minus 2.